Hello friends, welcome to the video series on interview questions for SQL PL SQL developers. So in this video, we are going to see about BTREE related index questions. So if you are watching this video for the first time, I would suggest you watch the previous two videos because this video is the part 3 of index related questions. The part 1 of index related question is covered in 18 where we discussed about what is an index, how to create index, how index help to improve the performance, and at a very high level we saw what are all the types of index and what type of index to be used in what scenario at a very high level. In the next video, that is in the video number 19, we saw about the metadata information about the index related things. So I would suggest if you are watching this video for the first time, watch the previous two videos for a better understanding. So now we'll start with BTREE related index questions. So I just given some list of questions which is related to BTREE. So through which if we find answer for these 7 questions, we'll be able to understand most of the BTREE related concept. To start with, obviously the first question is like what is a BTREE index? When you create a BTREE index, how the information is stored in the index segment. Once you created a BTREE index, where you will go and find the metadata information about the BTREE index itself. Okay, now that we have created an index, how to check whether the particular index is really getting used as part of your query execution. Next is like what is the scenario under which you will be creating a BTREE index, or how will you justify that you are creating a BTREE index for the given scenario. Fine. After creating the BTREE index, you need to understand few scan operations related to BTREE. This is very important question because mainly from the performance tuning aspect, that too mainly for experts, this question are being asked. Finally, we know that creating an index would definitely improve the performance. Then just because it's increasing the performance, can we go and create an index for all the column? So this is also sometimes being asked for intermediate or expert level of people. Finally, yes, there are advantages of creating index mainly for a performance improvement, but is there any disadvantage of creating BTREE index? So if we find answer for all these questions, we'll be able to cover most of the BTREE related concept. Okay, we'll start with the first question, like what is a BTREE index? Okay, BTREE is nothing but it stands for balanced tree. The moment we go and create an index on the column, Oracle creates a ordered list of value divided into the range. So what happens is the moment you create an index, it collects the information about the column on which you are creating the index and stores that information in an ordered list divided by the ranges in a separate index segment. And one more thing, along with the ordered data, the row ID information is also getting stored. So that is how it enables or it efficiently accesses the particular record whenever we use that particular column in the where condition. So from a simple question like what is a BTREE index, the answer is expected is it is nothing but an ordered list of value divided in the range along with the row ID information stored in the index segment. Okay, and the syntax for creating the BTREE index is very simple. It's the DDL statement, like create index name. You just give a name for your index. On is the keyword followed by the name of the table on which you are creating the index. So here you will be giving the column or a list of column comma separated. If you are giving just one single column, it is a simple index. If you are giving more than one column, it is a composite index. In case if the same index name is not used, you will be able to see a message saying that this particular index is created upon executing this particular DDL statement. So this is what is about what is BTREE index. Now we'll see how this information is actually getting stored. Suppose for a employee table given here, if you are going and creating an index on the employee number column. Okay, so now you are going and creating an index on this employee number column using the DDL statement, create index name on employee number. Okay, now we are creating the index on employee number. So what Oracle will do is it takes all these information, so it orders it and divide this information in a group, in a ranges, then store this information, that is employee number information, along with the row ID information in a separate segment, that is in the index segment. So just for a better visual aspect, so let us assume that it is just dividing this employee information employee number 1 to 14 into two groups, 1 to 7 and 8 to 14. Again within 1 to 7 it is just dividing into two more groups like 1 to 3 employee numbers, and 4 to 7, 8 to 11 and 12 to 14. So all these informations are now stored in the ordered way along with the row ID. So this is how it actually stores inside the index segment. Okay, then how it actually helps to improve the performance is, suppose if someone gives a query like select star from employee where employee ID equal to 5, then what Oracle optimizer will do is it knows that through the metadata information, it knows that there is a index already created on the employee number column. So it directly go to that index root node here. It will check where that particular 5 exists. So since 5 exists within this group, it will just go to that next node. Again, it will check where that 5 exists. It will just come back to this part. So 5 exists between 4 and 7. So it will start the search from 4 and it will just keep on searching till it finds 5. Also till it ends, because in case if the column is a non-unique column, chances are there are more than one number of record with the same value. So it starts with 5 and keep on goes till it finds the 5. So the moment it finds all the record which has 5, it takes all these row ID from here and directly go to the particular record, because accessing a table through row ID is the most efficient way of accessing the data. Okay, now this is how internally it works. It accesses the data. Suppose if the index is not there, obviously it will go for a full table scan. That means it goes through the entire information of this table and it keeps checking each and every employee number here, and finally it returns the record whatever matches with the employee number equal to 5. So this is how the index is stored, and this is how index helps in improving the performance of a query. So now we'll go ahead with the next question, like where to find the metadata information. Suppose you're creating an index and you need to definitely, when you're working, it's not just from the interview aspect. Most of the time when you're working, you just need to know, before even creating an index, you need to know whether the index is already created or can I use any existing index, all these things. So for that, you need to go and find the metadata information about the existing index. Let us just quickly go through one example, then we'll come back here. So here I have an employee table. I'm just creating a index on the employee number column. As you can see, the index is created. The first and foremost table you need to go is the user underscore indexes data dictionary. Just give your table name as the employee or whatever the table name you want to check. It just gives the list of indexes created on this table, where you can check the name of the indexes. When the index type is normal, it means it is a BTREE index. So here you will get the most of the basic information about the index. The next table is like user underscore ind underscore column, which gives the list of columns upon which this particular index is created. If it is a single column, you'll be seeing a single row for this particular index, or if it is like a composite index, you'll be seeing a multiple record. The next one is like user underscore in statistics. This gives about the information about the statistics of this particular index. So these are the basic table. If you want to know about more table, just check all the data dictionary table that starts with user underscore ind. So as you can see here, there are a lot of other tables, but whatever I've showed here is the most important, which will just give you the first cut of information for the index what you're searching for. So here is the list of basic table, but I would suggest you just go through the data dictionary to get all these things. But to start with, I would say these tables are more than enough. Let us start with the next question. How to find whether the index is being used or not. Suppose you have created an index on the employee number column, then you are just querying the table. Now you need to know whether the index you have created is getting used or not. The first way to find is the explain plan. Just do an explain plan for your query. It will say, in case if the index is used, then in the explain plan, you'll be seeing two information. One is you'll be seeing the access, table access through index. So this keyword you'll be seeing. Another is the name of the index by which the table is getting accessed. So there is third information here. Probably I'll talk about this a bit later. That is a unique scan you are seeing here, right? That we'll talk about a bit later. But this will tell you whether the index what you have created is actually getting used or not. Okay. When you do an explain plan, that is an estimated plan. That is Oracle is saying this is the plan which I'm going to execute. That means that plan has not been executed till now. So that is how the explain plan will just go you the predicted explain plan. But there is another way to check, that is by executing the query. You just run your query, then you check what the actual plan was getting used. That is from you just go to the select star from $SQL. That is $SQL will have all the information about the queries that got executed. In that data dictionary, in this view, just search for the query what you have just executed. Once you have executed, you will be getting a SQL ID. That is for each SQL that is getting executed in the system. This just gives an SQL ID. Just copy this SQL ID and search in another table called or another view called $SQL underscore plan for that particular SQL ID. Okay, just give the SQL ID as an input here where you will be getting the explain plan. So this is the explain plan that is actually getting used for this particular query. So these are the two ways by which you can check whether the index is used by the query. So when you have created the index, so this is how initially you need to check. There is another way to check the index, that is using an option called monitoring the index. Probably I will talk about this index monitoring in a separate video because that itself will take a bit more time. So just keep it in mind that is another way for you to check whether the index is getting used or not. Now we'll go to our fourth question. When to create a BTREE index? This is a very important question. Typically we'll create a BTREE index whenever the distinct number of columns are very high. Okay, for example, account number in a banking system, or a student registration ID, employee ID, a mail ID, a PAN number or Aadhaar number. So all these places will typically go and create the BTREE indexes only. But the key thing for you to check here is the cardinality. So wherever the cardinality is very high, then the recommended is BTREE, and wherever it is very very low, the recommended is the Bitmap. This might be another interview question, the difference between a BTREE and a Bitmap. Okay, so I would suggest, because typically when someone asked when you will create a BTREE index, they will definitely expect the term called cardinality. Okay, so cardinality is nothing but the ratio of the distinct value in a row to the total number of row. If it is very high, it means the number of distinct values very high. If it is very very low, then that means the number of distinct values very very low in the table. Now we'll start with the next question. What types of scan operations BTREE will do? This is very important question. Typically this will be asked for a performance tuning related interviews and mainly for the experts only. Okay, so there are few scans which will happen when we go through or when we create the index and when the optimizer uses that index. So I've just given here the most frequently used scan type, that is range scan, unique scan, full scan, min-max and fast full scan. Though there are few more scans available, these are the most important one you need to know. Once you know the basics of all these things, you can just go through and learn all the rest of the things by yourself. We'll start with the range scan. First we'll understand what is this range scan and where you will find this information about. So here is the employee table. I'm just creating the index on the employee number. So as I mentioned, this will just create a index data in a array, segregated by the range and ordered by the employee number. Now when you go and say select star from employee where employee number equal to 5, the moment you execute this particular query, obviously it will just go through this path and it will just pick this 5 and it will just take this employee row ID and it will just go. So this is how the execution will work. But what happens here is, just see this index is not a unique index, it is a non-unique index. I just mentioned create index, that's it. Since it is a non-unique index, there are chances that there can be more than one value with the same key value. So chances are that there can be more than one employee with employee ID 5. So what happens, once it comes to this point, it keeps searching till it finds all the 5. Though in this example there is only one 5, in case if there is more than one record with employee number 5, it will just go through the scan. So this is called a range scan. It searches for a range of value within this place. That is why it is called range scan, and you will clearly see the keyword in your explain plan saying that range scan. So the moment it is a range scan, that means Oracle is doing a range scan operation in its index segment. So this is how the range scan will work. We'll see the next scan type, that is called unique scan. So as the keyword itself says, it is a unique scan. For a unique scan to perform, you need to create a unique index. The only difference between the previous range scan and this unique scan is that I just mentioned I'm just creating a unique index here. You can see we are create unique index. After that, when you do a explain plan on the same query, you will be seeing a unique scan operation, right? This is because the moment it reaches this 5, since it is a unique keyword, since it is a unique index, Oracle know that there is no more record with 5. So it will just, the moment it finds the first key value with 5, it takes that particular row ID and directly it goes here. The one difference between a range scan and unique scan is that a range scan don't know whether there is more than one record or not, because it is not a unique index. Whereas in a unique scan, it knows that there can be a key value can have only one row ID. So unique scan is much faster compared to the range scan, and unique scans are recommended wherever you want to enforce the uniqueness, and it is much faster compared to the range scan. Okay, now we'll just quickly see the range scan and unique scan. The only difference, as I mentioned, is that it is the, when you say create index, it just goes through the range scan. When you say create unique index, it just goes through the unique scan. We'll see the next scan called index full scan. So as I'm just taking the same example, now in the employee table, I'm just now creating index on the salary column. The moment you create the index on salary column, obviously the index data will get stored. That is in a sorted order. So just for a convenience, I just gave only the index data here. I didn't give a range here. So as you can see here, the information sorted in the order of salaries stored here. So now the moment I say select sum of salary from employee, so this type of query. So what happens here is that, so now the salary information is there in two places. One as part of the table, the second one as part of the index. So we know that the index segment is much smaller compared to the table, because table contains all the information with all these other columns also. But index segment contains only the information about the column what we indexed, for which we have created the index. So the moment when you say select sum of salary, Oracle has two options. One is like just go to the index part, just take all these salary and do the sum. Otherwise, just go to the table segment, take all these salary, perform the sum. But going to the index segment is much easier, because index segment is much smaller compared to the table, and it is easy for the optimizer to read all the salary from the index segment itself. So in this scenario, Oracle just go through the entire index segment and read all these salary and just computes the total salary, where that is called the full scan. So you can see here the name of the index, and the option is the full scan. You can see here, this is nothing but Oracle is doing a full scan of this index data. So this is the index full scan. So the next one is index full scan only. This is also index full scan, but minimum or maximum. So whenever, so I'm just taking the same example. You're taking, having the employee table, creating the index on the salary. You can see the moment you say select max cell, because see, it is an ordered data. So if you want to take the max cell, obviously you can just go to the last segment. If you want to minimum cell, you can just come to the minimum, the first key. So the last key will tell you the maximum value. The first key will tell you the minimum value. So whenever you select the max cell or minimum cell, Oracle will directly go to the index and take the first or the last, depends. And that particular scan is called full scan min max. So here I have just computed max of cell. So here I have computed minimum of cell. So for both you can see it's just doing either a full scan, min max scan. So this is called the full scan min max. But keep it in mind, very important point here. Oracle will not index the data in case if the data has a null value. Oracle will do the index only for the not null value. I'll just explain you in a little bit with few more examples later, but just keep this point in mind. The final scan is the indexed fast full scan. I just want to give you one more example here. So here is an employee table. So here we are creating two index, one on employee number and another are salary column. And I just mentioned both are not null. That means all the information in the table will definitely available in the index. So that means since we have created two index, one on employee and another on salary, two information will be stored. So here is the employee number index data. So here is the salary information data. Suppose the moment when you say a query like this, select employee number comma salary from employee. In this case, since you are selecting only the column which are already indexed, now Oracle doesn't have to go to the table. Okay, it's not necessary to go through the table. Instead, it can just fetch from the indexed data itself. One from employee number indexed data, another from salary indexed data. It just combines these information and give you the output. You can just confirm that it is taking from the index from the explain plan, where you can see fast full scan. The moment it is fast full, that means it is taking from two different indexes and combining the informations, and it just present as a single output. So this is how the fast full scan works. Finally, can we create an index for all the column? We know that index will definitely improve the performance, but generally it is not recommended to create the index for all the column unless otherwise you are using all these column in the where condition. Very few scenario you will get such a question like I need to create an index for all the column. In that case, you don't have to create the index on all the column, because the moment you create an index on all the columns, you are actually duplicating the entire table data in the index segment also. Instead, you can create that table as an index organized table. Probably I will talk about this table in a detail bit later, but just keep it in mind that indexed organized table is nothing but you are storing the data itself in the sorted order of the index. That is called index organized table. The next question is, what are the advantages and disadvantages of B-tree index? Obviously, the advantage is that we are creating the index to improve the performance. But yes, there is a disadvantage, because whenever we are doing a DML operation, the index Oracle internally has to manage the index also. Every time you are doing an insert, Oracle has to rearrange the data whatever it is stored. So if as the table grows, the index also will grow. So if there is a huge DML operation concurrently happen, then the DML performance will degrade. Though your select statement will improve, though the performance of your select statement will improve, the DML statement performance will definitely degrade. So keep it in mind that there is a performance degradation in the DML part, whereas an improvement in the select part. So create the indexes only for the column which you are actually using in the where conditions. If you have any questions, you can just drop it in the comment section or just drop to my email ID. Thanks for watching. If you want to learn something new, please like this video, subscribe and stay tuned for new feature videos, interview questions, concept videos, tips and tricks, and SQL practice questions. Thanks a lot.